See, biasing circuit, R1, R2, RC, RL, RE and all you can physically see. But this THD is a performance parameter which you cannot physically see inside a transistor. It can be measured only from all the power values. Is it clear? Anybody is having queries? Anybody is having queries, please put it forth now. I'll wait for a few seconds. Because this concept has to be very, very clearly understood by you. Because these will travel till your 7th semester or 8th semester. There, if a faculty member asks you what is harmonic distortion, you should not blink. Harmonic distortion. Harmonics are integer multiples of your fundamental frequency. In general, I can say I can represent harmonics by this mathematical formula. It is going to be n into f. N into f. F is a fundamental frequency and n is going to be an integer. And can anybody say what is the value of n starting from? N starts from? What is the range of n? N will start from what value to what value? What is your fundamental frequency? How will you represent the fundamental frequency? Fundamental frequency is f, right? So you put n is equal to 1. Is that your harmonic? Is n is equal to 1 be called as harmonic? Will n is equal to 1 be called as harmonic? Yes or no? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
When will the harmonic start? We considered B2 as second order harmonic, right? So how will you get B2 when you put n is equal to 2? N is equal to 1 is your fundamental frequency. So the n value starts from 2 to infinity. N value starts from 2. Minimum value of n is 2 and it will go on till infinity. Okay, understand that clearly. See, in electronics and communication, there are places where I require harmonics. There are places where I don't require harmonics. So we have seen one scenario where I don't require harmonics. So what is the application where you don't require harmonics? Where you don't require harmonics in your circuit? Which application does not require harmonics? Please answer and make the class interactive. Otherwise, it's very, very boring for me. It is going very boring. Electronic circuits class, no interaction, nothing, no doubts. I don't know whether you're listening or not. We have seen example today of an amplifier where harmonics are not required. There is a beautiful example in electronics and communication where harmonics are required. See how in one place one parameter is considered as noise, in other place that parameter is welcomed as a signal. So that is the beauty of electronics. Okay, see, harmonics are fundamental integer multiples of fundamental frequencies, right? See, generally generating high frequency components are very, very difficult. The cost is very high, the circuits are very complex, so generating high frequency components are very, very high. But harmonics are naturally generating the high frequency components enough because of non-linearity of your device. So in applications where high frequency components need to be generated, harmonics are welcomed. In components like amplifiers where signal quality has to be preserved, harmonics are not welcome. They are considered as noise and they have to be filtered or they have to be kept at a minimum power level. Is this clear? The two examples where harmonics are required and one example where harmonics are not required. Any doubts or queries you have in that? Is it clear? Our concepts about harmonics are clear and familiar to you?